Hello everyone, welcome back to the channel. Today we're diving deep into the world of military technology to explore the most advanced military drones in 2025. As warfare evolves, unmanned aerial vehicles, commonly known as drones, have transitioned from simple reconnaissance tools to lethal combat systems capable of executing high-risk missions with precision, stealth, and autonomy. These modern drones are now built with the latest in stealth design, artificial intelligence, autonomous navigation, and high-tech sensors. They are not only supplementing manned aircraft but in some missions, completely replacing them. The rise of these machines marks a new era in warfare where machines play a leading role in strategy and execution. The design of modern military drones reflects the need for stealth, endurance, and adaptability. Most combat drones in 2025 are constructed using lightweight composite materials that absorb radar signals, making them harder to detect. These materials also contribute to the overall agility and fuel efficiency of the drones. Aircraft like the Northrop Grumman X-47C or Russia's S-70 Okhotnik-B have adopted a flying wing structure that removes vertical surfaces and tail fins, giving them a minimal radar cross-section. Their sharp angles and clean surfaces contribute to superior stealth capabilities. Modular weapon bays are hidden within the fuselage, only opening when the drone is about to release its payload. This further enhances stealth, as externally mounted weapons can compromise radar invisibility. Even drones like the Bayraktar Kızılelma from Turkey showcase an aerodynamic, sleek profile optimized for both speed and evasive maneuverability. Unlike manned aircraft, drones do not have traditional cockpits, but the space within them is densely packed with state-of-the-art electronics. These include high-speed processors, mission computers, data encryption units, and AI-based decision-making systems. Advanced drones are integrated with real-time communications satellites that allow them to be operated from thousands of kilometers away or even fly autonomously with pre-programmed mission paths. Drones like the MQ-25 Stingray have internal fuel management systems capable of refueling other aircraft mid-air, making them valuable force multipliers. What these drones lack in human presence, they make up for with artificial intelligence that can analyze threats, adapt flight paths, and prioritize targets on the battlefield. This level of autonomy allows them to respond faster than human pilots in high-stress scenarios. Performance is where the 2025 generation of military drones truly stands out. These drones offer a blend of speed, endurance, altitude, and strike capability. High-altitude drones like the RQ-180 can stay airborne for more than 24 hours, conducting deep surveillance missions while flying above enemy air defense systems. The Bayraktar Kızılelma can reach near supersonic speeds and carry a heavy weapons payload, including guided missiles and precision bombs. The Tyrannis drone developed by the UK is capable of high-speed flight and is fully autonomous, able to identify and engage targets with minimal human intervention. Chinese drones like the Wing Loong 3 are now built with a mix of surveillance, combat, and maritime strike capabilities. These drones can switch between roles mid-mission, making them incredibly versatile on the battlefield. Performance metrics like acceleration, maneuverability, and range are now rivaling, and in some cases surpassing, those of manned fighter jets. Fuel-efficient engines, high-capacity batteries, and advanced flight software are pushing drones into a new realm of operational effectiveness. Safety is a critical concern, and military drones in 2025 are equipped with multiple layers of fail-safe systems. Redundant communication channels, encrypted data links, and self-destruct protocols ensure that drones do not fall into enemy hands. Drones like the Hermes 900 Starliner come with civil aviation certifications, which means they can safely operate in shared airspace without posing a threat to civilian aircraft. Collision avoidance systems using radar, LiDAR, and optical sensors enable the drones to fly in formation or navigate through crowded airspace without human input. Some systems are designed to autonomously return to base if they lose connection with the operator, while others are capable of handing off control between ground stations or satellites. These features make them reliable even in environments with electronic jamming or cyber warfare threats. The integration of cybersecurity protocols further protects the drone from hacking or unauthorized control. What sets each of these drones apart is their unique selling points. The MQ-9B Sky Guardian, an evolution of the famous Reaper drone, is designed to operate across continents with autonomous takeoff and landing capabilities. It is capable of flying in both civilian and military airspace and can be configured for surveillance, combat, or electronic warfare. The Chinese GJ-11 Sharp Sword features advanced stealth with a flying wing configuration, designed to strike high-value targets in heavily defended areas. The Taranis drone incorporates a combination of stealth and AI-guided targeting, allowing it to operate independently for extended missions without a constant human operator. Some of the most revolutionary advancements are happening in drone swarms, where dozens or even hundreds of small drones coordinate as a single unit. These swarms can perform overwhelming attacks, conduct simultaneous surveillance, or act as decoys to confuse enemy defense systems. Each country developing drones is focusing on enhancing a specific edge, be it stealth, speed, altitude, payload, or artificial intelligence. The cost of military drones varies depending on size, capability, and mission profile. Tactical drones used for surveillance or small strike missions may cost between $1 million to $5 million. Larger strategic drones like the MQ-9 Reaper or X-47C range from $20 million to over $100 million per unit, depending on the onboard technology and support infrastructure required. These prices also include ground control systems, satellite relay stations, and maintenance logistics. Despite the high initial cost, drones are still more cost-effective over time compared to manned aircraft. They don't require pilot training, life support systems, or as extensive safety measures, making them ideal for high-risk operations where the loss of a human pilot would be unacceptable. Their long operational lifespans, combined with lower maintenance and fuel costs, contribute to their growing role in defense budgets worldwide. In conclusion, the military drones of 2025 are no longer auxiliary assets, they are now central players in modern warfare. From stealth reconnaissance to high-speed strike missions, drones are reshaping how militaries plan, execute, and dominate conflicts. Their unmatched flexibility, combined with autonomy and cutting-edge tech, enables them to perform roles that once required entire squadrons of manned aircraft. As nations race to develop the most advanced systems, the skies are becoming increasingly populated with machines that can see, think, and strike without hesitation. The future battlefield will be driven not just by human decisions, but by artificial intelligence, data, and high-speed unmanned systems operating at the edge of technology and strategy. Whether it's for intelligence gathering, deep strike missions, or coordinated drone swarms, these advanced drones are the spearhead of a new kind of warfare.